some of the ideas left in section 11.1 that we haven't talked about? Yeah. Oh, real quick. Somebody just came in. Ask other people. Go to the library before next Wednesday. Grab your Math 126 kit from the circulation desk. You with me? Go to the library before next Wednesday's class. Go to the circulation desk downstairs. Ask for your Math 126 kit. You just have to bring your ID. It's just like checking out a book. Feel like I never checked that book out? Well, then it's sort of like this. Go do this. So help me out. Remind me about this. If I had 27 people in a room and 9 of them are left-handed, what's the probability I pick somebody who is not left-handed? So I pick one person out of that room. What's probably I get somebody who's not left-handed? Yeah. So what goes on the top of every probability in the universe? Why'd you say 18? Because 18 people match what you're looking for, right? So the top is always how many match what I'm looking for. The bottom is always how many total things could happen. Yes? So 18 out of 27. Can you guys reduce that? Real quick trick from Math 125. How far apart are 18 and 27? 9. Does 9 go into both? So I don't know if you guys remember this. If you took me, I talked about this a little bit. I'm sure you kind of talked about this idea. If I'm trying to reduce a fraction, I can only divide top and bottom by a number if both the numbers are multiples of that number, correct? Like they're in the list. If I'm in the list of multiples of 9, any two things in a list of multiples of 9 are going to be some multiple of 9 apart from each other. Does that make sense? So if I subtract top and bottom of a fraction, the only numbers that could possibly divide into both must be factors or multiples of that number. Factors of the number, I should say. So like those are 9 apart. So 9 could go in, and of course 9 does go in. So you get 2/3. Anyone know what that is as a decimal? I'm sorry, as a percentage? 66.66666. So let me ramp this up a bit. And this would be a good way. I think almost everybody has filled out the survey. There's a link in Canvas. If you haven't filled out the survey, I think there's only like 2 or 3 of you that haven't done it. If you can get in there and fill it out for me, that'd be great. There's a link in Canvas to a little survey. I have put together a little table. So go ahead and copy this little dude down. So this is the people that have worked at a school in some capacity. Yes, no. And this is, they want to teach a level less than 3rd grade. So like kindergarten, 1st, 2nd. Yes, no. You guys see what I'm saying? Like the most immediate little table I can think to make from the questions I asked you. Have you guys seen tables? I'm sure you've seen tables like this before. Yes, where the rows indicate something and then the columns are subgroups of that thing. Can somebody tell me what does this 6 mean?
It's people who have worked at school but don't want to teach less than 3rd.
Exactly. So people that have worked at a school, they said yes, but they don't want to teach less than 3rd grade. They want to teach 3rd or up. Yes? Okay. Now, not surprisingly, most of you guys want to teach like 1st, 2nd, 3rd, some kindergarten. Yes? I don't blame you. It's kind of nice that there are some people out there that want to teach like middle school, 6th, 7th, 8th. Some people want to teach 9th. Now let's get into high school, so that's like secondary, but I will. Okay. So let me ask you a probability question. If I pick one person that filled out the survey, what's the probability that they work at a school? worked or work currently at a school. So it's a really good thing to do before you start to try to answer any probability questions. Because what are you guys doing right now? I want to know the probability somebody, I pick one person from this group, it's probably I get somebody who worked at a school. Yes?
11 out of 22.
So what did you have to do to get that answer?
Add up again.
Yes. So a really good first step is go ahead and add up all the columns. So this would be 14, this would be 8, this would be 11, this will be 11. Can somebody tell me how many total people I talked to? How many total people did the survey? 22. So not quite everybody. So like Tyndall said, there are 11 people that match what I'm asking for. They worked at a school. 11 people have worked at a school out of 22 people, so that's what percentage? Holy shit, 50%. One more easy one before we get into the little more tricky ones. What's the probability somebody wants to teach higher than, how do I say this, or equal to, sure, Jeff, make it all mathy, 3rd grade. What would that be? So probabilities, it's crazy. We're not going to get as deep into probabilities as it would in my stats class, but we're going to do a little bit more than just basic. But every probability is always the total things that match what I'm looking for divided by how many things could happen. So what are we looking for?
Who wants to teach?
Yeah, people that want to teach higher than 3rd grade, or equal to 3rd grade, 3rd or higher. I could have said that. That would have been great grammatically. How many people is that? 8 out of 22, because it could have been anybody, correct? I picked one person from memory, so it could be any out of the 22, but 8 out of the 22 match what I'm looking for. Can you understand if somebody says 1 out of 8? This is the most common mistake on this kind of question I ask. And they'll say 1 out of 8. Can anyone tease out what their logic was? There is logic there. It's definitely the wrong answer, but I understand what they were thinking. Does anyone see that? So, yes?
There's 8 total no's and they wanted 1 person.
Yeah, there's 8 total people and they wanted 1 of them. But that's not quite, you can see the logic. And this is so cool. Well, this is one of the hardest part about teaching. One of the hardest things about teaching is when somebody gives you the wrong answer and you're trying to figure out what were they thinking. Now, if you want to be a really bad teacher, you spend no time trying to think what they were thinking. Then you can't figure out how to connect. You can't see what parts of the thought process were right. You can't figure out how to explain why they were wrong. You guys see what I'm saying? But oh my God, dear God, sometimes I'm like, what did you do? So I'm trying to see what was the logic. So I can see, was it something I said that they misinterpreted? What was it that they did wrong exactly? That's one of the hardest things about teaching sometimes, is figuring out what the hell went wrong. So if they say 1 out of 8, they're thinking about it a little sideways. If I add 8 total people and one of them was the one I wanted, that would work. But I've got 22 total people, and any of these 8 would satisfy what this problem was. Okay, maybe, and then you can reduce it and you can do all that kind of business to it. I think it's 0.36. Thank you. So 36.4% or something roughly. Yeah. Okay, how we all doing? So, by the way, the name of this thing when I make a table like this, it's called a contingency table. So like the number in the box is contingent on where it is. So there's 5 because it's a yes and a yes. So we call it a contingency table. So what did I say? That was 36.4%, I think, roughly. So what is the probability that I pick somebody who doesn't work at a school and wants to teach less than 3rd grade? I'm aware that my word choice there is a little weird, but oh, I'm a math guy. Give me a break. Probability, I pick somebody who does not work at a school and they want to teach less than 3rd grade. They want to teach under 3rd grade. Lower than 3rd. So if you just go back to the basic idea of probability, the top is the total number of people that match what I'm looking for. So let me ask you this real quick. And this is going back to 125. Do you remember and or? Yeah, so what I could have done for myself. No, I won't do that. Do you remember what symbol we used for and? Shaboo! Yes. Do you remember, if you took me, I talked about a bouncer, I think. I don't know if you guys remember this. Or I talked about scholarships. Yeah, if you go to apply for a scholarship, back in my day, we didn't have the internet and stuff, so we had this giant book. You go to the financial aid office, and they have this giant book, and you crack it open, you start looking at the scholarships, and it says, you must be a math major, check. You must have been born in Georgia, check. You must have this GPA, barely, you know. So, the number of people that are eligible for every line decreases because you must meet all the requirements. So and is like that, it's very restrictive. It says you must do all of these things. So the answer to an and probability will always be smaller because there's less people. So how many people meet both requirements?
Could be like -11.
Sorry? So they must not work at a school and they must want to teach less than 3rd grade. So, what's true about these people? Those 2 people, what's true about them?
Most they didn't.
They don't work at a school, yes? But they don't want to teach less than 3rd grade. So, what do I want to include those people? Nope. So, I can't say 11 because that includes people I shouldn't include. Who are the only people that both don't work at a school and want to teach less than 3rd grade? None. Which is another reason why, I can't remember if we said this in 125, but we also call and an intersection. It's the intersection of those 2. So this would be 9 out of what? 22, good, because I'm picking somebody from the group. It could have been any of them. And then, I don't know, whatever the hell that is. You gonna try it, Jeff? No.
41.
What is it?
44.9%.
44.9%.
We're at 41.
41?
Yeah.
I'm just taking whatever he said. Okay. So one more question, and this one's kind of important. This is the big one that the book kind of focuses on. What is the probability that I pick somebody from this group and they worked at a school or they want to teach less than 3rd grade? So the or thing is nice. The or thing is it increases. So if only scholarships said You must major in music. Damn, or, sweet, I'm still in, right? I'm not immediately excluded, so or always increases the number of people that could be included. So I call and the mean bouncer and or the nice bouncer. So the mean bouncer says you have to dress nice and you have to have money and you have to know Joe. I don't do any of those things. The nice bouncer is you have to dress nice, shit. You have to have a lot of money, shit. You have to know Joe. I know Joe, so it's the or this, or this, or this. As long as you do one of them, you're in. So what's true about the students I'm going to include in the numerator? They must either work at a school currently. How many students is that? Yeah, 11. Let's get it down. So work at a school, there's 11. How many want to teach less than 3rd grade? 14. Now here's the problem. If I do 11 students who do this and add 14 students who do this, how can I tell I'm wrong?
More than 22.
Yeah, it's more than 22. What the shit? I just created 3 people. Right? Which I normally can't do that quickly. Yes? Bam! They're there. So what have I done? What mistake have I made? If I add those 11 people to those 14 people, even what I just said, I've made a mistake.
Some of those people intersect.
Some of those people intersect. Some of those people are the same people, yes? Yeah, I like it. So how many people, can you guys see how many people I counted twice? Exactly how many people did I count twice? 5. Why did I count those 5 twice? Because they're in both groups, right? So it's like those 5 people should get to vote twice. Okay. No matter how much they want to. -5. Now, 11 over 14 minus 5 is 20. That's 10 over 11, which is roughly 0.91. I think it's like 91%. You guys with me? Is it? You guys can double check it. Don't just accept what I said. Now, what is it?
90.9.
90.9, exactly. So, no. I want to overanalyze this for a second. Because I'm a math teacher, we do that. It's pretty cool if I do this. Mathematically, is this different? Mathematically, is this different, what I just wrote? Of course not, it's just fractions, right? As long as they have the same denominator, I can put them together. Can anyone tell me from the work what probability statement this would be? What's this represent? Oh, you really can't tell, kid, because there's 2 11s. Damn it. All right. But from what I say up here, the 11 is the work at school, yes? So that's the probability they work at school. I'll call it WS. Plus, what's the 14? Yeah, they want to teach less than 3rd grade. I'll say less than 3, is that cool? And then I have to subtract off what exactly? How many people, what people did we subtract off? This probability was that they did both, that they work at a school and they want to teach less than 3rd grade. Okay, so now we have actually developed the formula for OR. So let's write that with less freaky words and symbols, right? So if I have, so we got all this business? If I have an event A, an event B, and I want to know what's the probability of A or B happening, that would be the probability of A happening plus the probability of B happening. Now that by itself makes intuitive sense, but that's the mistake we did earlier of adding people twice. If I add all of A to all of B, I've got to subtract any that are in both. And you might as well use, I'm so used to teaching stats where I don't use this symbol, but you guys know that symbol. So if I look at, how do you guys feel about Venn diagrams? Oh, non-committal, okay. You know, just do it, Jeff. Oh my God. So if I want the probability of A or B, visually you can very quickly see, if I add all of A to all of B, you can very quickly see I added something twice. And that part I added twice is exactly the intersection. It's exactly the and. So there's a visual kind of proof of this. Okay, I like it. Okay. Not too bad, not too bad. Yeah, let me do this. All right. I want to show one video from a student working with a probability question. And while you're watching that, I'm going to figure out what order I want to do something here in a minute. Has everybody got that? Let's find out. Yes. Let's see if everything's set up for this. Doop. Doop. Let's see if the sound is good. Where's the sound? There it is. Sound looks like it could be good.
So, there are two different coins.
Sorry. I wasn't talking to you. I was talking to him. I can't record that. You just point in that general direction. I don't need the lights. Even if literally, that's one way to represent the sample space. It could either be both heads, both tails, or one head. Yes? Even then, why can't you say 1 out of 3? What was it we talked about with sample spaces? Why can't I just see there's 3 things and I want one of them, so 1 out of 3? Are they all equally likely? No. Because what did we just say? How many ways is there to get 2 heads? 1 way. How many ways is there to get 2 tails? 1 way. How many ways is there to get 1 head? 2 ways. So that's more likely. Yes? Okay, so let's see how she recovers. And by the way, if you didn't take me for 125, did your teacher as well, like Carrie, did he show you these videos? I'm always curious. Okay, well, you were with me, so you're like, I don't remember you, Jeff. I thought you were Carrie. Okay.
Okay. Now, what are all of, go ahead and list out all of them.
Did she capture all the triangles? No. Did she count some that weren't really triangles? Yes. Can you see why some of what she did makes sense? What was one triangle that she picked that wasn't really a triangle?
One that's open at the top.
Yeah, good. So one that she picked later. She kind of looked at it earlier and then came back to it later and said, "Oh, I better." And I really like the way she's kind of staring at him, like, "Am I doing okay?" So this one, can you understand why a student who's as young as this might say this is a triangle? Right? There's a few different reasons why they might say it. It's got 3 sides, correct? So they don't focus maybe, so what we're about to get into are the levels of analysis of geometric shapes. So your first level is really rudimentary. So you have this standard idea of a triangle. You don't even necessarily realize the characteristics. What was wrong with this guy? Does it have 3 sides? Yeah. Does it have 3 angles? Yeah. Is it connected? Yeah. So what's wrong? It's curvy. Yeah. And for a triangle, the sides are supposed to be straight. Yes? Now, real quick, there's 2 things going on here in general. When you are teaching mathematics, and when you're teaching anything actually, but obviously I can only speak about math, as you're introducing a new subject, and you guys have lived this, you don't know what to focus on as a student. So part of a teacher's job is to be really careful that the examples you give are broad, right? If every triangle I ever draw looks like this, and if I asked, and this is one thing I was thinking about doing and I totally forgot, if I ask just a person off the street to draw a triangle, a large percentage is going to draw this, yes? What percentage is going to draw this triangle?
Very small.
Very few. In fact, if they do, you're like, okay, what do you do? You math teacher, what are you all about? Because that is a triangle. That's not what I think when you say triangle. I think this, yes. In fact, what's the triangle we think of normally? What kind of triangle is that? Equilateral. I like it. You guys got it? So we're going to identify, I don't know if you've ever taken any psychology classes and there's stages of development in somebody's life, and I'm sure you should have to as part of your, yeah, if I say Piaget, does that sound familiar to anybody? Yes? Okay. I think I got that right. Piaget stages of development. We're going to talk about the stages of development in terms of ability to analyze geometric shapes, right? And they're named after this guy. I've heard, it's really interesting. I'm going to call him Van Hilly, but I've heard Van Heel, so it's Van Hiele. So it depends on who you ask as to how to pronounce his name. He's no longer with us, so I can't ask him. So let me show you here. So she is operating on a level 0. All right, so we're going to talk about each level here in a minute, but it kind of makes sense. The kind of mistakes she made tells me kind of what level of thought she's doing. How clear cut is every level? Not very, yes? You don't suddenly graduate to the next, you can still make some mistakes, but you got some understanding, then you say you're at the next level, okay. Let's watch another one. You guys remember her from last semester? Yeah. Okay. Let's see, yes. Oh, shice. There you go, thank you. Oh shit, did I turn my camera back on? If you're a teacher and you're trying to get a student to be okay with rotations means it's still the same shape, what kind of exercise could you do with your students? Because they can identify, if you have a bunch of students, they all know 7 is a square, but very few of them understand 2 also is. What could you put in front of them as? Tiles. So first you have tiles that are lined up so they can see it's a square, and then you just come around and you just turn them, or you ask them to turn it or something, right? And you say, did I change the shape? Did I give you a different shape? Didn't you say it was a square? I mean, you can kind of get them in the right direction then, yes? And and again, this one's a little bit easier for you guys to grasp. I think that you can understand the progression. I wanted to bring with you, I saw on social media at some point, I don't know why I always see these dumb things. I wanted to show this to you. It was somebody complaining about the way that they teach students how to add. So she kind of did 41 plus 63 48 plus 63, she carried the 1, correct? And then somebody who's like 6 was doing it the way we did last semester, which is they added 8, 3, got 11, and they added these 2, and then you put the 1, the 1 was a 10, so it went the other 10s, you know, and they're all making fun. Oh, they're teaching math different. And we talk a little bit about this in Math 125. You're gonna have parents who are gonna call you up and come talk to you and say, why are you teaching it like that? Why aren't you just doing it the way I know how to do it? So one level of that is explain how you gotta build it up to that point, but also say, you did learn it like this. You just forgot. It's been forever. Are you kidding me? Right? Compared to how much time you spent doing it this way versus carrying the 1, you're gonna forget that little bit of time you did it this way. Okay. So let's see what happens.
Okay, I would like you to put an S on every shape here that is a square.
Square? That's all.
Okay, now I'd like you to put an R on every shape.
So real quick, he got the one that I pointed out could be a problem. So it seems like maybe he's operating higher than level 0, because level 0 normally can't handle rotations. Okay.
Rectangle.
Well, let me say this. I think he's a rectangle, right?
Rectangle.
Yes.
That's all.
Okay. And now I'd like you to put a P on everything that is a parallelogram. You know what a parallelogram is?
It's one of these.
Okay.
Wait, so I put button on.
Okay. So are there any other parallelograms?
Oh, this one is. Oh, no. And this one isn't, so it'd have to be this one.
Are there any others?
Yeah.
Is that all of them? So how do you decide when it's a parallelogram versus a rectangle?
Rectangle is a shape. It's like a cube that's stretched out.
Ah, okay.
Long.
All right. And what about a parallelogram? What are kind of the characteristics of a parallelogram?
It's a rectangle that got stretched to here, to here, to here.
Okay, it's kind of like a rectangle but
Or it
stretched.
got stretched from there and there and there.
Okay,
Not there, just this one.
okay. All right, thank you.
Okay, so we don't know yet. So that'll be level 1. Level 1 is where you start to notice the characteristics, the definition, what makes something a triangle. So if they would have given him the same thing the little girl did a minute ago, it's just because she's younger. He would have probably picked the triangles a little better. He would have noticed the ones that were really freaky were still triangles because he notices the characteristics. 3 sides connected, straight lines, yes? He's putting together not just the shape by observation, but he's putting together the definition, the characteristics that make it that shape. Okay, maybe. So that would be what happens at level 1. What else did I want to say? There's one more thing I was hoping maybe somebody would bring up, but let's see. He didn't bring it up. And if you were with me last semester, you understand how I feel about this dude. He kind of leaves some things, there should be some questions he asked. But let me go back to the paper. So we talked about the fact that square is a certain kind of rectangle. But what are the parallelograms? He kind of had trouble here, didn't he? Is this a parallelogram?
Yeah.
Yes, it is. Why?
Because this 2 sides are parallel together.
Yes, all you need is both sides parallel. Yes, so each side being a parallel side. Yes? So with that definition, is this a parallelogram? Yes, good. But it's specifically a rectangle because it is a special kind of parallelogram. Yes? Okay. Maybe. So level 0 would say that's a square, where'd it go? That's a square, but that isn't. Level 1 would say those are both squares because I know a rotation doesn't change the fundamental idea of what it is. If I stand on my head, I'm not suddenly Frank, I'm still Jeff. Yeah? Okay, did I record that? Am I gonna? I did, damn it. I'll be right. I gotta edit the video. Okay. You guys all with me? Okay, so maybe, let me see. Did I want to do one more right now? That's from 11. Yeah. Oh yeah, let's do one more. Let's not record this one, Jeff. Okay, so this theory was developed by, like I said, his name is Van. We can call him Healy if you want to. So I'm going to do a brief overview of the different levels, and then each section basically drills down further into each. So with this theory, level 0, this is where they just are given a stereotypical triangle, so they're not able to handle rotations. They don't pay attention to individual characteristics. They kind of have this standard in their head, and if it doesn't match the standard, they throw it out. They don't think, does it meet the definition of triangle? Does that make sense? No? Shit. So they have this like template, and if it doesn't meet that template, it's thrown out. They don't stop and think, well, does it have 3 sides? Does it do this? Yeah. Or they include it even when they shouldn't, because it looks close to their template. Blah, 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 blah. Yeah, it's more of a, let's see if you guys call this, it's more like a holistic recognition. Like, it's not drilling down to the specifics. Okay. So this would be the general math issue that goes with level 0 students are the examples you give. You have to be very careful to not give examples that exclude certain possibilities, because then they sort of start to really hone in, oh, that's what needs to be a triangle, and you didn't do an example like the bigger angle. So they kind of exclude that because you never show them that example. Okay. Level 1. Oh, by the way, level 0 is called recognition. Level 1 is called analysis. And this is like we're saying with the little dude with the cool freaking dinosaur shirt. This is where you start to actually focus on definitions and characteristics. The rotations don't change what shape it is. But the kind of trouble that level 1 still has is realizing that a square is a specific kind of rectangle. A rectangle is a specific kind of parallelogram. Yes? Now, what is the word that encompasses all 4-sided shapes? Quadrilateral. So very often, a really good activity is to have a whole bunch of shapes and say, identify the 3-sided shapes, identify the quadrilaterals. Now just look at the quadrilaterals, which ones are this, which ones are that. Because that sort of focuses them to start thinking in a definitional way. Because what is the definition of quadrilateral? 4 sides. So now they're in that mindset. Blah, 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 blah. Yeah. So this one has trouble with larger relationships. Has trouble realizing squares are types of rectangles and so forth. Level 2 addresses that, or doesn't address it, it's where they kind of start to understand that last part. Level 2 is called relationships. Yeah. So this is where they start to connect between rectangles and squares. There's a certain word I haven't used yet. If I want to make a parallelogram, what can I start with and then shift it a bit? Sort of like what the little dude said here earlier. Start with a rectangle. And then I like that way he was trying to say it. I don't know if you understood what he was saying, but he said you could, if you pulled both sides of these corners, that would make a parallelogram, because then it would go, yes? What if you start with a square, which is a rectangle, but it's a specific kind of rectangle, and you pull on it? Does anyone know it is a type of parallelogram? But it's given its own name also. Rhombus, kick ass. You guys remember that word, rhombus? And again, you don't use this too much outside of your geometry classes, and I'm gonna blame you, but, so a rhombus is a parallelogram where all the sides are the same length. So it's kind of like the same relationship a square has to a rectangle. A rhombus has that relationship with a parallelogram. So this is the kind of idea at the relationships level that students start to key in on. How are these related? You with me? They don't see a rhombus as being completely separate from a parallelogram, right? Okay. Or a square. They kind of understand a rhombus is a square that's been shifted. So, right? So a square is a special kind of rectangle, it's a special kind of parallelogram, it's a special kind of rhombus. That's the stuff they could do in the level 2 step. See anything else I want to say? Oh, sure. They can use deduction to justify observations from level 1. Meaning, in level 1, they are starting to get the definitions down, but in level 2, you can use the definitions and you can use the, so use the definitions more fully. Like the definition of a parallelogram leaves it open that a rectangle is also a parallelogram because it matches the definition. Okay, maybe. So level 0 is just, you give them a basic triangle and they can see that, but if I turn it, if I had it standing like this, they might say it's not a triangle. Then they kind of start working towards level 1, where they can see, okay, rotations don't change it, but then it's more of a definition thing. They can identify a square even if you rotate it, but they won't realize they could also call that a rectangle. Yes? Then you get to level 2 and you start to kind of fill that in. Okay, I like it. Now the funny thing about the next 2 levels is they're probably higher than, what's all over this pen? They're probably higher than what some of you guys are going to get to with your students, but let's talk about them. Here we go. Level 3 is called deduction. So this is where we actually start fully doing this. And this is kind of like what you did in high school. This is where geometry becomes a formal math system. You start to move in the direction of really simple proofs and such. Do you guys remember, we're not quite to this level, but do you guys remember in high school when you did, you might have done it more recently, angle side angle? You guys remember that? Kind of stuff. And you had like proofs and you had corresponding angles and you had transversals and all that kind of business. That's more of a math system. It's got visual components to it, but you've got axioms and you got theorems. It's becoming more of a math system. And then you got the ultimate level here. This is called axiomatics. Oh my God. I think I just said this word. You see, it uses axioms. So this is very abstract. You have your postulates and you have your axioms. It's more, well, this is actually more like college level stuff. This is where you can start talking about very quickly. Remember that one circle, Jeff, you get that. That one triangle that had the circular sides, the curvy sides. If I blew up a balloon and you try to draw a triangle on it, and you kind of look at it from the side, isn't it going to be curvy sides? Okay, so we're not going to suddenly do this, but I want you to understand. The geometry you use in high school is called Euclidean geometry. So have you ever heard the math guy, his name is Euclid? It's okay. It's okay. You don't have to. So Euclidean geometry is flat. Flat. So if I want to draw a triangle, it's got straight sides, it's got 180 degrees in it, yes? If I talk about the surface of a sphere, that's non-Euclidean, because now it lives on something that's not flat. The angles don't have to add up to be 180 degrees. I can talk about the outer surface or the inner surface, and it could be more or less than 180. So that's all I'm going to say about that. Sorry. I just like to, everything you do, there's probably another level to it, trust me. So geometry is one of those things. We can suddenly go, a flat plane is nice. What does it look like if I'm on the Earth, for example? We're on a sphere. Okay. Oh, good. So let's drill down a little further, and I want to show you some pictures from the book for level 0. So let me show you this. This is the kind of problem you would give to somebody who's at this level. Oh, just passed. 552. There we go. So this one you could just give to a student, and number one, I mean those two are tricky. Let's look at this one. They just gotta look cool, right? Real quick, does anyone play Wordle? Do you guys know what Wordle is?
Yeah.
So a friend of mine just showed me, there's like a whole slew of things. There's the New York Times. There's one that's kind of related, that is really funny because I looked at it for the first time and then I looked at this and I was like, holy shit. It's basically tiles and you have to match them up. You know what I'm talking about?
Yeah.
And I think the name is Tiles or
Tiles,
something.
yeah.
Yeah. But doesn't that look like?
Yeah.
Okay.
It has more patterns.
Now, if you've never looked at it, you don't have to. It's not a prerequisite for the course. I just wanted to point that out in case anybody's seen it. If I gave a student that first figure, the one with the orange and the gray, and I asked them, can you find any shapes, just any shapes that we've talked about? What shapes do you think they would come up with?
Square and triangle.
Yeah, squares and triangles, yes? Would they necessarily identify, oh man, why is it so? Would they necessarily identify this as a square? Maybe not, right? Because it's been rotated, correct? But what would they obviously identify as a square? Maybe the whole damn thing, yes? And maybe this piece here, yes? Maybe these little dudes here, yes? Now, why might they have trouble possibly identifying this as a square? Just for this specific example.
Because I see two triangles.
Good, because there's two different colors for that one thing. They might not realize you can just throw that together. But this is, this kind of problem, they want to draw, they want to get examples of shapes because they want to incorporate that in drawings that they themselves do. The second picture might be a little bit, whoa. But the first picture is kind of cool. Kind of gives you ideas of different kind of shapes you can make yourself. Does anyone else, do you see any other shapes in there? Squares, triangles, any other specific named shapes? Ooh, where do you see a trapezoid?
All the little black pieces.
All the little black pieces. Can you show me real quick? Come on up.
So all of these little pieces.
Ooh, okay, beautiful. Okay, perfect. Okay. So then you can really drill down and you can see these lines here. And it's the first time today we said the word trapezoid. But why is that a trapezoid? Can you guys all see what we pointed out? So just look at those little lines and you can tell why a lot of students would probably miss that because they're just looking at the big ones. That's a trapezoid because why?
There's a set of parallel sides.
Good, set of parallel sides.
Sides that will end up.
And these two are not, right? So I just like to think of it as a beheaded triangle. So it's like a triangle that somebody chopped his head off, yes? I might have watched too many Game of Thrones. Anybody see anything else?
Hexagons.
Hexagons?
Like the two.
Where do you see one? Can you show it?
The two trapezoids, like together with them.
Oh, okay, good. So like right here. Okay, cool. So that's one thing we're going to do this semester is we're going to identify going up the number of sides of what each thing is named. Kick ass. So I mean, you start to drill down and see a lot more things if you drill down. And this is really good to kind of like see which students seem to do that naturally, and then which students might need some help realizing the flexibility they have with how they connect images in this. Now, the green and yellow one, that's a lot more intricate. Actually, this is a lot more intricate than it first seems. This one, what's this here? Again, it's a hexagon. And then what about these little dudes? It's a parallelogram. It looks like it's probably a rhombus, because these look like they maybe are the same length, but I can't tell until I get a ruler out. Yes? But can you see a larger hexagon? So they're the little ones. And then you got the big ones here, yes? So the neat thing about this problem for students is a lot of people get a chance to be somebody who sees something first, right? Because they desperately want that. So there's a lot of things that are easy to miss. And so you get a decent chance for somebody to notice something somebody else doesn't. So I mean, you want to give them that experience. Anything else anybody want to point out up there? You guys see, the stars, obviously, right? The different shades of green. Yes. Okay. Blah blah blah. Let me see. What did the book find? Anything else interesting? Parallelograms, outline in black. That's an interesting book. Okay. Oh, down here they have actually discovering some stuff. So here is a beautiful little parallelogram in that one picture there. Over here, they identified the little, let's see, did they call it a rhombus? Squares, rhombi, I love it. Rhomboids. Okay. So those kind of search activities are good because number one, they just look neat. And number two, you have a good chance to find something somebody else didn't find yet. Yes? Okay. So coming back, let's see. Oh, that's right. I couldn't remember if I had said something else. Where am I at? Oh, so zeroing in on recognition real quick. Whoa. There we go. So this is where, like we just did, an activity, very well traditional activity you can give is the search for shapes. You can also give activities that are kind of related to what we watched earlier. You just give a bunch of figures like the triangle, some were, some weren't, and just ask them to circle all the triangles that they see. Because that leads to a good discussion about why some things they thought weren't triangles really are. You're trying to push them towards level one. Yeah, so obviously the thing that level 0 students are going to have trouble with is, for example, they might have trouble seeing this shape here because they're not thinking rotationally, yes? They kind of want rectangles to be like this, and they want squares to be like this, and they can't necessarily identify rotational stuffs, which is where you say, everybody take your paper and turn it like this and look again, right? Okay. Search for shapes. Rotations will be an issue. And by the way, a lot of the stuff that we talk about in here, it's related to, I should really try to put together like a book list. Because a lot of the stuff we're talking about in here is related to how the mind starts to make links between information it receives. So this isn't like we're forcing students to go through these levels. This is an observation we've made about humans, yes? So there's a lot of good stuff. If anybody has time, you should take some psychology electives. And I'm not sure, again, I'm pretty sure there's some things you have to take for your elementary education degree. But the more you understand adolescent development, yes? Or, because you can start at birth and then the general stuff we've noticed about humans and what they're going through. Because whatever grade you're assigned, it's really good to have an idea of what stage of life are most of these people going to be at. It's going to affect how you teach and how you interact with them. Oh. Sure. So somebody already said this earlier. So a really good activity here would be actual physical manipulatives. Like we used that last semester, we're going to use again this semester. So like all the shapes we use for fractions, those can just be looked at instead of fractions as the shapes themselves. So that's where you can do the rotation thing and make them realize that's still a square, that's still a rectangle, so whatever, even if you rotate it. Physical manipulatives are really good for them to work with. Blah, 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 blah. You start to get them to categorize shapes. So the real surface level, the ultimate surface level, how many sides does the shape have? Then it can drill down for everything that's three-sided, this, for everything that's four-sided, we can drill down shapes, yes. We haven't even talked about like isosceles versus equilateral versus scalene. Does any of this sound familiar? Yeah. Scalene is the one that everybody has the most trouble with. It's the triangle that almost nobody would draw if you said draw a triangle. Blah, 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 blah. Oh yeah, there you go. Sorry. I just said what I had written right there. One thing that's going to be in your little kit. Okay, so let me show you an example of this. This is why I should have had you get this already. But so, for example, here, real quick, before I show you what I was about to, here's a collection of 4 and 3-sided. So the very first basic level would be circle everything that's got 3 sides, circle everything that's got 4 sides, right? Then you would start to, within these groups, now obviously triangles, there's equilateral, isosceles, blah, blah, blah. Quadrilaterals, you've got squares and so forth. This doesn't even include slanty dudes, parallelograms, rhombi, which is a good idea for when you're first starting out. So you got a jumble of shapes. You do one surface level categorization, and then you start to subcategorize within. Now, real quick, do they tell you? Yeah. What did the student think if they put them into these groups? Let's focus on the triangles real quick. What was the student thinking? And again, they're level 0, so they're just looking at the shapes. Why would they put those separate? They're all triangles, right? So obviously, what is it with category 1? What type of triangle does it look like it's trying to be? Isosceles, kick-ass. Isosceles triangles are specifically triangles where it only has 2 sides that are the same length, so 2 angles. So I always think of like, if 2 sides are the same length, the mouth opens the same amount, yes? So if this mouth is as big as that mouth, these 2 sides are the same length. You guys are kind of with me? So just like a square is a certain type of rectangle, an equilateral triangle is a specific type of isosceles. It just happens to have all 3 sizes. Okay. And then over here you can obviously tell they've got the idea of square versus rectangle. Now one thing that's really interesting about this is if they're level 0, they might not actually be cool with this guy because he's rotated, yes? But they can at least see if you would have prompted them and said, can you make a little grouping that has all sides are the same length and another group where they aren't, then they could probably do this. They might not realize that's a square, but they know they have all the same length. Okay. Oh, okay, so here's what I actually was gonna show you. There is a little thing called a geoboard. It's also known as square dot paper. So a geoboard actually has pegs that you can put rubber bands. Some of you guys are nodding your head like you've used them before. Where have you used them before? I'm sorry, go ahead. When you were working at school? Oh, okay. Same thing, or? Yeah? So we'll use some of this. And then of course you also have paper where it's just dots. And you can connect the dots and make these, but it's always more fun when you can put a little bit, giving rubber bands to a room full of kids, that could present its own challenges. Yes? Okay. So you'll lose an eyeball. Then you have something related, which is not surprisingly called a triangular geoboard or triangular dot paper. If you don't want to give people little rubber bands, you can make your triangles. Yes. And then of course, it's kind of nice because instead of just drawing, they're actually physically putting something together. They've made this triangle and have more of a connection to it. And then of course, if you rotate it, they're like, oh, that's a triangle. Now it isn't. Well, yes, it is, because it's the same thing. Okay. Just a different physical manipulative they can work with. Sorry, I had this note for myself, but I can't read. Oh, this kind of resistance. Oh yeah, sure, of course. Yeah, this is related to what we saw earlier in the video. If they ask us which one of these are triangles, a levels 2 student would say what? Possibly, more than likely. Which ones are triangles? If you're a level 0 student. Yeah, probably a decent amount of them will say 1. They might not identify 2. Isn't 1 closer to the stereotypical? Yes. 2, sort of like with the little dude, it has like a 90-degree angle, but they still see it as like a wedge or something. They're like, that looks like a doorstop, or that looks like a whatever. Yes? So they might not even identify that as a triangle. Okay. Okay. By the way, if you had me last semester, you understand how I kind of operate. I'll have days that are lecture heavy, and then the next class I'll have a little worksheet. So the next class will, after the quiz, I'm gonna bring back the little, putting people into groups based on the little picture. So we'll see what clip art I find that is not copyright protected that I can put on these little things. But last semester I had an Axel Lalo group. I think everybody's favorite was the broom group. Okay. Let's talk a little bit about level 1, and then I'm gonna actually let us out just a bit early. This is getting, by the way, this is officially getting into 12.2, if I remember correctly. Yes. So in level 1, we start looking at these shapes more deeply, and we start defining the characteristics that tie them together. But there are some side things we start to do also. So this is the analysis level. So we're analyzing geometric shapes. We're looking at the components of the shape. Oh my God, I'm way zoomed in. There we go. We're analyzing geometric shapes. We're looking at the components of the shape instead of just the holistic whole thing. We're starting to zoom in on the components. Bless you. And we start to look at stuff like, even beyond the definition of a triangle being straight sides, 3 of them connected, right? We start to do some little side things. And the first immediate little side thing we do, oh man, you can see them. I'm using the back side of the stats test, looks like. The first immediate like side note we go on is talking about symmetry. Now, what's your immediate reaction when I say symmetry? Anything immediately come to mind? See? Similar. Even. What shape has the most lines of symmetry? So let's do one example. Can everybody draw an isosceles triangle for me? For me, that is absolutely stunning. That is like, I almost connected it too. Yeah. That's like a true question. Can you find a line of symmetry? And what do you think that means, even if you never really heard it put like that? Like in algebra, just to really bring back some trauma. When you guys did parabolas, wasn't there a line of symmetry? And that's just where the mirror would go, correct? So for me, it would go right through my head, right? Because then if I fold this, so symmetry, you can think of it as if you folded the object, what would make it lie on top of itself? So with this triangle, how many, isosceles triangle, not equilateral, specifically isosceles, how many lines of symmetry are there? There's definitely one, correct? The one that goes right through his head. Yes? I don't know why my math is always so violent. So if I fold that over, are there any others? Could I go like this? Because that would overfold, correct? Yes. Now I'm thinking about pizza, damn it. Oh well. Can't go that way, I can't go this way. I mean, do you guys, anybody think there's any more lines of symmetry than this one? No, there's not. I like it. I like it. Can you draw a triangle that has more than one line of symmetry?
Yeah.
Yes, what kind of triangle?
It's not a perfect triangle. It's just the one where it's the same on all sides.
Yes.
I can't remember the name.
So sides are lats. So lateral, and they're all equal.
Equilateral.
Equilateral, yes. So if I draw an equilateral triangle, pretend like that's equilateral. It's not really. I'll be okay. Then this will work, and this will work, yes? And see how it's kind of related to rotations? If I can rotate it and it's the same image. Later we'll delve into, if I rotate an isosceles triangle, how far do I have to rotate it before it lines back up with itself? All the way around, correct? How about an equilateral triangle? If I rotate it a third of the way, it lines back up with itself. A third of the way, it lines back up with itself again. And then another third of the way, it lines back up with itself. Do you guys see what I'm saying? So we can bring in rotational symmetry eventually. Well, actually, right now. So this is what's called reflection symmetry. What shape has the most symmetry? The most lines of symmetry?
Squares.
All right, well, square has how many? Let's talk about it. So square has how many lines of symmetry? Kind of like that's a square. So again, if you want to, you could even think, you could bring in something I sort of talked about, rotation. If I rotate it 4 times, it'll line back up with itself each kind of click. So let's look. There's more than that though, really. If I look at just reflection symmetry, doesn't this work? Doesn't that work? Yes? Doesn't this work? Doesn't that work? Yes? So that's why reflection symmetry is not the same as rotation, They do sometimes have similarities. Any more than those? 1, 2, 3, 4. Any more than those? I don't think so. Okay. You got one? Oh, sweet. Okay, I'm sorry. So for a square, there's no more lines of symmetry, but there is. But that's definitely more than we've had yet. So that's good. But then you want to go to even more, you have a circle. How many lines of symmetry does a circle have? Infinite, kick ass. So it's got, Jeff, what are you doing, buddy? So if I draw a circle, it's got this, obviously. It's got this, but then it's got this, and then it's got this, and it's got this. I mean, every little tick mark you can make, start here, and then move the smallest possible amount over, there's another one. And then move the same amount over, there's another one. And so how many lines can I make? Like you said, infinite. I like it. Okay, well that's pretty straightforward. So you all understand the basic idea of symmetry. We can get more specific with certain types of shapes. Can you draw a shape that has no line of symmetry? Or a little shape. So I can leave it wide open. How about a triangle? Can you draw a triangle that has no line of symmetry? Yes, do it. All you need
It's a acute angle, and one on side, and then connecting back to the.
so something like that.
No, where there's no right angle.
Oh, okay. Something like the little dude had trouble with, like this.
Yeah.
Does that have a line of symmetry? Ain't no way. Yes. What about this? Does it have a line of symmetry? Nope. Poor little dude. All right, so it's very easy. In fact, if you just draw a generic shape without thinking, more than likely it won't have any symmetry. Just sort of like go for it. It's not going to have a line of symmetry. Okay. We all know the basics of symmetry. Blah, blah, blah. Oh. Yeah, so, how do I want to incorporate that? Oh, real quick, before I go there, just to shut the door on symmetry, you've also got rotational symmetry. Rotational symmetry is different from reflection symmetry. So bring in the square back. It's got 1, 2, 3, 4 lines of symmetry. Yes? Rotational symmetry is how many degrees would I turn it so that it would line up with itself again. Right? So if I turn it 90 degrees, it's a square again. Yes? Turn it 90 degrees, it's a square again. Yes? But you see how the rotation doesn't take into account this reflection symmetry here? I don't stop here because it's not a square again yet. Or at least not the same square, I should say. It's not this. So rotation symmetry, I can't remember how specific the book gets. Rawr. No. Blah, blah, blah. Oh, here we go. I don't think they drill it down to actually figuring out angles and such. No. Okay. Okay, cool. So one thing to do, what's an activity you can do with students to give them a hands-on experience with symmetry? Bringing this back. What's one thing you can actually give them to work on? Give them to play with. So, analyze some symmetry.
Like square, but like in paper. So like,
Yeah, so if you give them a little square construction paper, you say try to fold it so that one side laps over on the other side. Yes? You guys kind of with me? You need the isosceles triangle, and you can say, every time you fold it a different way, count that. You have a little contest. Let me know if you think you have the most folds or whatever, right? Now, if you give them a circle, there's gonna be some little kid who's gonna go crazy. I folded it. Okay. And then, of course, give them one that has none, and let them worry about that for a bit. Okay. Let's see. So every time, yeah, that's one thing I need, I think, to do a better job of. You're not going to believe this, but I don't have a backlog of worksheets like this because I don't know if you guys, I know you, those of you who've taken it before, you know I never taught elementary school before. It is not required to teach this class to have done that, but I always feel like I'm lacking in something because I can talk about, I was in an education program in college, but that was to teach high school. So I have done studies about pedagogy and philosophy behind education, all this kind of stuff. I've done those kind of courses. A lot of your college teachers haven't, by the way. But I have never taught elementary school, right? So I've seen a lot of things. I've watched a lot of videos. I've read a lot of books, but I always feel like I'm missing that component. So that's why I'm going to try to bring in people's experiences. So several of you in the survey said you do work at a school. And normally at this level, you've done that. And at some point I want to bring in, and this happened last semester, if I remember correctly, we were doing something and somebody said, oh yeah, I did that with these kids. And I'm always curious if you have firsthand observation of some of the stuff that we're talking about, right? A long time ago, I did tutor students who were in 4th and 5th grade. It was at, I can't remember the name of it. They had Roadrunners as their, it was Newtown, that's right, it was on the East Coast. And that was so cool. Just to kind of work with them and try to figure out how to explain really basic math stuff. And I'm like, I gotta figure out a different way. Anyway, I wanna try to bring some of your experiences into this. So as I do these things, one thing I'm not good at, and I need to reach out and get some more of this, is to give you example worksheets teachers have used in their courses, for example, right? Or just activity sheets that you can give the students. Those are pretty freely available, so I should be able to just go find some, but yeah, I'm always so focused on the concept, but that's something I could do more of, is to bring some of that stuff in. Let me see what's on. Oh, okay. Yeah, okay. So once you talk about symmetry of objects, you can then start to drill down to the components of objects. So can anyone use geometric terminology? How did I just create that square? Or let's say rectangle, yeah. How did I create it? What did I put together? What did I combine? 4 sides. Now be more technical. What is a side? Here's a side. Line segment. So if you connect 4 equally sized line segments, you get a square. Yes? So then you can ask students, okay, do you see? So they come to you at level 0 normally, because they've already lived in the world, they've already seen shapes. Normally, you know, parents will purposefully do this, or accidentally they'll start to notice shapes. You're trying to move them towards level 1 or help them get there. So level 1 is about drilling down to the parts of a shape. So then you can start talking about line segments. You can say, where in this room can you see a line segment? Can anybody see line segments in this room? And if you tell me, float around my head, I'm like, oh, okay. I don't know if you took too much or too little bits. Anybody seen the line segments? Can you point one out to me? Are they around us? Yes. I love it. There's line segments up here. Kick ass. Yes? And see, this is the activity sort of like earlier where students have an opportunity to point something out that maybe somebody else didn't notice. Give me another one, just a little more. Another example of a line segment.
The lines around the screen.
The lines around this screen, yeah, this dude. I like it. lines between the cabinet doors. I mean, the lines up there in the curtain things, and they're all over the damn place. Yes? Okay, you could say, on my page, you see a whole bunch of little line segments that I put together into these things called letters. Math boy, okay. Alright. Okay. I think I'm gonna let us out. I said I was gonna let us out early. So I'm gonna stick to that. Next time, so we got a little bit in 12.2 just now. 12.1 is an overview of all the levels, and then it focuses on level 0. 12.2 focuses on level 1, and I think it gets into, I can't remember if it gets into level 2, no, not quite yet. Monday's a holiday, so you can come to school, it's just not much gonna be happening. And then Wednesday, of course, is our quiz, if I remember correctly, on 10.1, 10.2, 11.1. Don't forget, what's your homework assignment in addition to your work? Get the kit. Go 126 kit. That's all you gotta say. I need my math 126 kit at the circulation desk, and they'll give it to you. Cool. Let me know if you have any trouble. I've already talked to them, and they know you're coming, so okay.